I am going to show you some calculations and graphing in Excel so that you can transfer these skills to any lab you do in ESS. In order to accomplish this, I have completely made up an experiment and some numbers to go with it. This experiment involved exposing fruit to light for varying amounts of minutes and then evaluating how many grams of fruit were eaten by bats at night. Yes, it's totally made up. So there were 8 locations evaluated, or 8 trials, for each variant of the independent variable. Here are on the left you see the variance of the independent variable, 0, 5, 10, 20, and 30 minutes. You see that one area was not measured at one time for that particular variant, so there are only 7 trials instead of 8, because sometimes that happens. In this experiment, the rate of fruit eaten in 24 hours will be determined from the average of grams eaten in the night. First of all, the scientist needs to organize the raw data in Excel. I highly recommend giving your tables in Excel titles so you are always aware what all the numbers mean. In this case, I have labeled the imported raw data. You can see here the amount of fruit eaten in grams by bats in the presence of light minutes. Okay? Then a scientist always takes the averages of all the trials for each variant of the independent variable. Remember, Excel can do all the calculations for you. You see, I have labeled the column average so that I will know that the numbers in this column are the averages. Then I signal to Excel that I want it to do a calculation by inserting an equal sign. Then I type in average, and typically a drop-down menu will come up, and you can see I use average a lot, so it's my most recently used. It's also going to be in the list here if you don't use it very much. So you select average, and then you highlight the numbers that you want to average. So starting with trial 1, I'm going to average all the trials from 0 minutes under the light. And if the cell remains blank, Excel will just ignore that number, and I will get an average. And remember, I can now drag this down and get averages for all of my values. And remember, we want to keep the decimal places the same for all of our numbers. And so remember, you can go up here and make them all the same. So our scale measures to 2 decimal places. And now we have the average to the right number of decimal places. Next, we will calculate the standard deviation. Just like with the average, we can signal Excel to do that for us by typing in STDEV. It will crop up, and then we're going to take the standard deviation of that same set of data. Okay, and again, what is the standard deviation? That is the spread of your data across the mean. So you're going to do that for each of the variance of your data, and we're going to ignore that error. Okay, so now I'm going to take these averages and calculate a rate. So let's look at how we're going to do that. Here's the experiment. The research question was, how does light exposure to fruit affect the rate at which the fruit is eaten by bats in a specific area? So the research question has this word rate in it. It's not how does it affect the grams of food eaten, which is this, but the rate. So we need to calculate the rate before we actually graph the data. So in order to do that, you have to know that the data was collected over 8 hours of nighttime activity in a quadrat of 5 squared meters. And this is the formula for rate. Rate is equal to the mass divided by area times the time. That looks a little bit similar to NPP, doesn't it? So you might be doing another calculation like NPP, but for this example, I'm going to do this rate. So we go to Excel and signal that we want to do a formula with the equal signs. And then we go back here and we see, we need the mass, and that's in column K, row 3, so we type in K3. And then we have to do divided by the area, and I told you the area was 5 squared meters, and then the time was 8 hours of nighttime activity. Okay, and then we get a rate. How many grams of fruit are eaten in every cubic meter in every hour? Okay, so now we want to do the standard deviation for the rate. So we can't just use this standard deviation, can we? Because what are the units of this standard deviation? They're the same as the average, because it recognizes that, you know, our deviance from the mean is about 4 grams, and we need to convert that into the same units as our rate as well. So we're going to apply the same formula for the rate, the standard. We're going to apply the same formula that we used for the rate over the standard deviation. So we need to take L3, right, divided by the area, which was 5 times the 8 hours of daylight activity, right, so that our units make sense with the rate. Okay, so now we have a standard deviation for our rate, and so now we can use this to do our graph. So in order to do the graph, I find it easiest to simply retype in exactly what you're graphing. Well, not really type in it, but copy it. So I copied the independent variable information here, and now I'm going to copy this information. Okay, and so Excel doesn't like to copy formulas like this, because once I move this here, the formula, it can't take the information to the left of this, right? So to fix that, you just right-click and select Paste Special, and you want to paste the values. Okay, and then it will transfer the numbers nice and neat for you. And now you can do a graph. Okay, so what kind of graph are we going to do? We're going to select the independent variable versus the average rate that we just calculated. And we are going to insert a scatter plot. Okay, and so now we have a beautiful plot here. And then I want to insert the error bars, right? So we add a chart element. The error bars, we are going to customize our error bars, right? We're going to specify the value that we want our error bars to have, and this is, right, this is the value for on top, and then we're going to do the same thing for on the bottom. So you can either copy and paste like I did or reselect it. Okay, and now we have nice, pretty error bars. We don't want horizontal error bars though, so we'll just select that as 0. Okay, so now we only have our vertical error bars. The other thing we want to do is to insert a trend line. So we do that by inserting a trend line. We want a linear trend line. There it is. We can also add the r-squared value right there, and you can even move it around wherever you want on the graph, right? And so that tells you how well your data fits to the trend line. And then of course you have to give your graph all its proper titles. So this might be graph number 1. The rate of fruit eaten in response to light exposure. Remember, your graph has to tell your story. Okay, I'm going to go ahead and add in an axis title here for the horizontal axis. Okay, and what is that represents? This is time of light exposure, and it is in minutes. It's a little bit tricky to add the vertical axis because, again, we have that squared unit. So I'm going to show you how to add that in your sheets. So you're going to copy your graph, just did that, and then take it into your sheet document. So after you've copied your graph, then you go to your Google document that you're writing your report in, and you're in the process data area, right? So you already have all your raw data in there. You have your process data, which is the average of the fruit eaten. You have the rate of the fruit eaten that we just calculated. Okay, and then you describe how you determined your data here. Now, I did not put an example in for average, but you should have average determined as follows. And then, like I did here, where I have rate determined by the following formula. So you have the formula, and you do a sample calculation. And you say where you're doing that from. You're doing it from the 0 minutes. And then you put in the rate is equal to the 12.57, right, grams divided by the 5 meters squared times 8 hours. And then you have those units. So you can do your units like this or your units like this. It's the same thing. Okay, and then you describe that you also applied that same formula to the standard deviation, how you got this information. Okay, so make sure to also include the averages. So you come in here and then you paste your graph. Okay, so what you're going to do is you're going to insert a drawing, and then you'll paste your graph in here, and then you can edit it as you will. Now you'll see that I have pasted the graph in with none of the labels from Excel, because then it will have a uniform look in Google Sheets. So now I'm going to add the 3 different labels. I'll show you how to do that. Okay, so we can add a text box, number 1. Alright, so that's one label. Okay, then I'm going to do another label for the rate. And truthfully, it's easier just to copy the units from your Word document, which is what I did. Okay, and then I'll add the other one. I won't make you watch me do that. Okay, so now I have the different labels, but you'll notice like the font sizes aren't the same. So you can change that up here, right? I can make them all the same. So right now it's Arial, size 12, and you just want to match it to whatever it is that your document has. And I'll leave the title a little bit bigger. So now I have the proper labels with the units, and I save and close, and there it is in the Word document. Okay, so I hope that helps you going from raw data to process data to make thoroughly good processed data.